Hello guys, so today we're going to finish off statistics. Last two topics are linear regression equations and correlation coefficients. So before we actually begin doing any of the statistics, I want everybody that has a TI to go ahead and get it out. We need to make it display our R, our correlation coefficient. To do that, just turn it on, go to your home screen, go to second, then 0, catalog. Then you're going to hit the letter D. It's the X inverse button right here. We find diagnostic on. Right there. Hit it, hit enter. Make sure you're highlighting diagnostic on. And then once it's displayed on screen like that, hit enter again. It says done. If you don't do that, your TIs won't calculate the R value, the correlation coefficient for you. So go ahead and do that first before we begin. Okay. So correlation. It's basically saying if two variables are related to one another. And the correlation coefficient, R, tells you how strong that relationship is. So both of your calculators can find the R value from a set of data. I'm not going to get too in detail with these. I'm going to have one correlation coefficient, one regression equation on the test for, and one or the other on the final. So it's just a little piece. So don't worry too much about it if you don't understand, but it's not that bad. So again, R measures the strength of correlation. So if one variable is somehow related to another variable, then that's called a correlation. In this class, we're only going to be looking at linear correlations. It's possible that they have other kinds, but in this class, we're only considering a correlation if it's linear, and that's what R measures, is a linear correlation. So imagine, here's a scatter plot of X and Y data, whatever it may be, who cares? But we're going to see if these X values are kind of related to these Y values in some way. And if you can look at it, you can kind of see it goes in a line. It's not so random. It's got a line going through it. The exactness of that line, how well it forms a line, that's what R measures. So you see here, this one's got the dots are closer together, the points are closer together, so it's more linear. If you notice the R values, it's the 0.851, it's the 0.965. Notice I ignored the negative. The absolute value of R tells you the strength of that correlation. The closer it is to 1, the higher the correlation. If it's 0, there's absolutely no correlation whatsoever. But a -1 and a +1 are the strongest two correlations. If it's positive, they're directly related. So as one goes up, the other goes up. If it's negative, they're inversely related. As one goes up, the other goes down. No, that's what I just said right there. So if you look at this, these are just random dots. There's not really any kind of line you can draw through these points that would make any sense. So that's no correlation at all, 0. And this, you can see it makes a nice parabola here. But again, we're only looking at linear correlations in this class. So we'd consider this to not be correlated. See, it has an R value of 0.087, really close to 0. So that's not helping here. So of course, we got our requirements we have to follow, and they will be met. Given any collection of sample data, paired data, the linear correlation coefficient R can always be computed, but the following requirements should be satisfied when testing the hypothesis or making inferences about R. So we can always calculate R, but is it going to mean something? Well, to make sure it means something, the sample of data is random of independent quantitative data. So make sure it's not, just, hey, what do you think? Hey, what do you think? Do you think Trump should stay president? What do you think? It's got to be some random sample. Still got to be that random sample. Voluntary response is not random. And if you look at the scatter plot, the points kind of need to look like a straight line. If they don't look like a straight line, and R is still somehow closer to 1, it's just not very good. It could happen that one's way up here and one's way down there, but if it doesn't look like a straight line, and it doesn't have to be a perfect straight line, but if it doesn't look like a straight line at all, then it should not be used to make inferences about the data. And if you screw up, take the data out. So you're measuring blood pressure or who knows what, and you sneeze, and it makes a jump whenever you're calculating it. Well, don't use that data value. Okay, there's a lot of variables that we're going to have to deal with. We could get all these from a set of paired data. However, one of two things is going to happen. One, I'm going to tell you what each of these numbers equals. Two, I'm going to give you the data. If I tell you what these numbers equal, you plug them into the formula in your calculator and hit the enter button. That's R. If I give you the data, you type the data in your calculator. One in one list, the other in the other list. There's going to be two sets of data. For a TI user, you'll be putting it in list 1, list 2. Casio users, well, you just have two different spots to put it in. And after you type in the data, you hit a couple more buttons and it gives you R. I'm not going to have you calculate each of these from a set of data or anything like that. So you should know what all of these say. You should be able to read them. N is the number of pairs of data present. So if you have, let's say, 10 pairs of data, N would be 10, even though you'd have 20 numbers to type in the calculator. Sigma means summation. Sigma x, sum of x's, sigma x squared. You should know what these mean. Now, y, that's the other set of data. So sigma x, y, that means you're multiplying the x value times the y values and adding them all up. R is the correlation coefficient. And rho is, when we're looking at a hypothesis test, that would be our population parameter right there, rho. So again, it's a complicated looking formula, but it's really not going to be that bad at all. You're just going to type it in the calculator and be done with it. Now, to tell if that correlation actually means something, to decide if it's significant, yes, more hypothesis estimate, we're not going to do anything formal. We got a chart. Here's a snippet of it. So we have an alpha value of 0.05 or an alpha value of 0.01. That's the options. And you just look at what N is. And depending on that, decides what R value would actually be significant. So that is in your geometry. That is in your formula sheet. It's actually before the Z table. It's right here, stuck in the middle. Table A6 right here. That's the, if you look at the front back, this is the second page, front of the second page. And it's just hidden right in there. And right here, chapter 10, is where all of our formulas are going to be. Yes, they look big and complicated, but it's just sticking numbers in the calculator. It's not bad at all. You can all push buttons. So here, let's just jump to an example. We've got a set of paired data, okay? So I'm going to take my calculator, and I'm going to type it in. I'm going to start with the TI, and then I'm going to use the Casio. If you don't have either of these calculators for some reason or another, even though you should all have the Casios because I made sure you had them, well, you'll have to calculate all the variables by hand, and that'll just be terrible for you. Sorry. TI users. So if you're on the home screen, go to Stat and Edit. So what we need to do is clear out lists 1 and 2. So go to the top, highlight them, clear, enter. They both need to be completely cleared out. We type the X's, this row, into list 1. y's into list 2. For calculating correlation coefficient, it doesn't matter which one's in list 1 and list 2. However, whenever we get to regression equations, it does matter. So go ahead and get in the habit. X is in list 1, y is in list 2. After you have your data, quit. You're back at the home screen. So we're going to go to Stat. We're going to go to Calculate. Number 4. List 1 for X's, list 2 for Y's. Leave that alone. Frequency list, not happening for us. So regression equation, I don't even think you have that option. So I believe it'll just look like that for you. Hang on, let me see if I can get that. I believe it'll look something like this, just this right here. You should be able to just hit enter after that. As long as you have list 1 as X's and list 2 as Y's, that'll be fine. If you do anything else, you have to put these parameters in there. But if you just hit that, it'll assume list 1 is X and list 2 is Y. So again, Stat, Calc, number 4. You probably don't have that option. It's going to pop up with that thing on there, and there we go. Here, R equals negative 0.956. Okay, let me clear this for a second. If you didn't do that very first step I showed you on the beginning of this video, this is what you're going to look like. It's not going to have R. So if you come to this point for some reason, you didn't pay attention to the first part of the video, right now, go to the catalog, hit the D, go down to diagnostics on, hit enter and enter again. Then whenever you do that and run your linear regression, it'll pop up with your R. So that's it for the TI users. I'm going to snippet this screenshot. So if you notice, it already has other information here too, A and B. That's actually linear regression, so you can do both at once. That's what it'll look like on the TI. Casio users. Okay. We'll get back to mode 1. Okay. So you're going to go to mode number 3. And we actually need to do number 2 here. Usually we do number 1 variable. But we actually have, see how it's A plus BX? And see how here it's AX plus B? That's the linear regression equation. So that's the mode we need to be in. Stat number 2. 2. And you see it has X's and Y's. Oh, look, it has X's and Y's. I bet you can figure out where those go. So type them in and then just go down. There, bring it number 1. Make sure, after you type in your X's, your first Y slot is numbered 1 right here. Don't screw up. 5, 8, 6, 4. Oh no, what do we do now? Same thing we did before whenever we're doing a 1 variable, where you hit the AC button. Notice we're still in stat mode right here. Now we're going to go to shift number 1, just like before. And look at these options. Which one do you think? Which one do you think? Let's look at number 5. Oh, look at that. We have A, B, and R. Huh. We need R right now. And let's compare it. negative 0.956182887, negative 0.9561828. Oh, same thing. Yeah. Okay. Now, for the next part of this lesson, you could probably figure it out from this point. We are going to go to number 5, and we're going to use A and B. That's going to be our constant and our slope. But that'll be later. So for both calculators, it's really easy. If we have the data values, just type them in and you're done. So let's examine this correlation coefficient. Well, oh wait, I think that's actually the next question. Okay, I was jumping ahead of myself here. We'll wait. Now let's do it by hand. Here's the formula. Here's all the variables. We should get the same thing for R. I'll do it in both calculators. So if we look, does it have a multiplication symbol here? It does not. Okay. Make sure you understand that this is multiplying right here. I think the TIs would understand that, but the Casios won't. So just to be safe in both cases, put the multiplication symbol. I'll start with the Casio, just because I started with the TI last time. So get out of here, AC, if you're in that place, mode 1, back to the normal calculation screen. We got a fraction, so hit the fraction button. N. I didn't put N down here. Oh no. Well, let's go back and look. There's 1, 2, 3, 4, 5, 6, 7, 8 numbers. So N is not 8, it's 4. Remember, it's the number of pairs of data. 1 pair, 2 pair, 3 pair, 4 pair. So N is 4. Make sure whenever you're counting N, you're counting pairs of data. 4 times sum xy is 61 minus sum of x is 12 times sum of y is 23. Okay, let me go down. I got square root 4 times sum of x squared is 44. I'm still under that same square root, minus sign. Sum of x is 12, and we got to square that. So be careful. This is not the same. These two are not the same thing. Notice this square is outside parentheses, that square is inside parentheses. That's the difference. So we're done with this square root. So I'm going to go to the right and hit the multiplication symbol just to make sure the calculator knows what we're doing. And we're basically going to do the same exact thing except with the y values. N is 4 times sum of y squared is 141 minus sum of y, 23, and I got to square it. And if I typed everything in right, I should get the same R value. Oh no, what did I do wrong? Nothing, I didn't hit the SD button. There we go. So it takes a minute to type it in, but really it's typing in numbers in the calculator. It shouldn't be that bad. You will be given the formula. You will be given all the variables. Just type it in, people. TI users, you have a little more work to do because you don't have the fancy math type. Unless you do have the fancy math type with the TI-84. Let me make sure mine's actually off. Not that format. Oh, no. Classic. There we go. So this should look more like your calculators. Okay, so whenever we're typing things in, start with parentheses for your numerator. Then type in your numerator, adding parentheses as needed. 4 times 61 minus 12 times 23. That's the end of my numerator. Put a closed parenthesis. Put your fraction bar, and open a parenthesis for your denominator. Now, this parenthesis is for the denominator. I'm not going to put a square root. Notice I have another open parenthesis. That's for the square root. The first parenthesis I close will be right here, and that'll be for the square root. So that's all that goes in that square root. So I'm going to put my closed parentheses for the square root. My denominator is still open. I haven't closed it yet. I closed this one. Times another square root. And again, it opens its parentheses for us. 141. 3 squared. I'm closing parentheses for my second square root. And now I'm closing parentheses for my denominator. And there we go. We get the same thing. Just be careful with your parentheses and it'll be fine. And of course, if you want to, you can just use a Casio if you have to type it in by hand. I don't mind if you have two calculators. Whatever you prefer. Now we're going to determine if that R value is actually significant. So we need two pieces of information. We need our alpha, 0.05, and we need our N. N was 4. So we're going to look up the critical value from this chart. N is 4, alpha is 0.05. So I'm going to go down here. N is 4, alpha is 0.05 right here, 0.950. 0.950 is my critical value. Anything more than that, then we're going to say, yeah, it's significant. Let's see what we got. R was negative 0.956. We only have 3 decimal places. We're going to round to 3 decimal places. So yes, it is significant. Why, even though this is negative? Because we're only looking at the absolute value of R. Remember, the absolute value of R shows the strength. That positive or negative, that just shows whether it's directly related or inversely related. So we just look at the absolute value of R and compare it to our critical value. If it's greater, there is a correlation. And that's about as formal as we're going to get. We're not going to do formal hypothesis tests and all that good stuff. We're just going to compare it to our critical value, like yay or nay. We're not going to look at a two-tailed, or well, we are going to look at a two-tailed test. This is always going to be a two-tailed test. We just compare it there. Now, don't make the assumption that because there's a correlation, there's a causation. That is not true. Just because two things seem to be related doesn't mean that one caused the other thing. Let's think. So if you compare the prices of Domino's pizza and a train ticket, like a subway ticket in New York or something, they're going to go up together because inflation, you know, it as the value of money goes down, the price of things goes up. Doesn't mean that pizza caused train tickets to go up. No. There's a correlation, but not a causation. All right. Averages suppress individual variations and may inflate the correlation coefficient. So don't look at averages of data, look at the whole data. And again, there could be a relationship that's not necessarily linear, but we're only looking at linear relationships in this class. That's it for the correlation coefficient. Now we're just going to talk about the regression equation. And we're going to look at the best line that goes through that set of data. That's what the correlation or the regression equation is. Same kind of thing. We're going to be using the calculator. And both calculators will compute it for you. If you have the data to type in, well, here's the formulas, we're going to type it in. And we're going to try and make sure the data sets are small. So let's do one. So same data. So TI uses you're in luck, it's still in there. Three one three five 5864 5864. So then you already have your data in there. You just go to stat calc number 4 and hit calculate. Notice it's AX plus B for you. Casio's, I think it's backwards. So what we have here is AX plus B. That's what we care about. It also tells you what A and B are. So the regression equation, y equals AX negative X, because it's 1 times X, plus 8.75. Done. That's the regression equation. Casio users, we're going to go back to mode stat 2. You're going to have to type the numbers back in. Every time you get out of the stats mode, you have to retype everything. So it doesn't save it for you like the TI does. But it's just 4 pairs of data, so it's not that bad. Okay, make sure I'm in 1. Yep. AC out of there. Shift 1. Again, we're going to go to regression. And we need A and B. So I'm going to see what A is. A is 8.75. So I'm going to write that down. I'll screenshot it rather. And I need B. B is -1. Okay, I want to go back and look at something in the mode. I got a mode 3. Look at what number 2 actually says. It says A plus BX. So if we take this equation, we plug in these numbers. Here's B. Here's A. Y equals A plus BX. So plus and negative makes a negative. These are the exact same thing. They're just written in a different order. So Casio users, your calculator formats it like this. TI uses your calculator formats it like that. Both of these are the correct equation. We're good to go. So of course, we still need to be able to do this by hand because it's likely that if they do give you one of these on the final, they'll just do the numbers and you have to type it in by hand. Let's do it. And I don't remember those equations at all off the top of my head, so I'm gonna go grab them from my formula sheet. So I'm gonna grab all this because it's what you're gonna be looking at. So here it is. Y equals B naught plus B1x. So here's B1, here's B naught. So the Casio and the TI use A and B. This uses B naught and B1, whatever. If you do go into a science kind of major, or if you just happen to take statistics or physics, sorry, you'll understand what this subscript means. B naught, that's the initial condition, and then B1 is the next condition. So that's why they have the constant as B naught, because that's the initial condition. So let's just type this stuff in. Where's Casio? There it is. We're gonna need to go to mode 1 for this. Mode 1. So I guess I'll find out what B naught is first. I'm gonna use this equation. So I've got a fraction, sum of y, that's 23, times sum of x squared. Let me move this up a little bit. Times sum of x squared is 44, minus sum of x, 212, times sum of xy, 61. Except for the numerator, for the denominator, I have n is 4, times sum of x squared, minus sum of x squared. Let's see, this is supposed to be B naught. This should be 8.75. Oh no, oh yeah, there it is. So there's B naught. Now we get B1. We get this equation here, n is 4 times 61 minus 12 times 23, n is 4 times x squared, 44. Where's 12 squared? Sorry. Yeah, that's -1. So now TI users, same exact thing, just type it in, watch the parentheses. So clear off your screen, make sure there's nothing on there. Yeah. I'm gonna pause the video right here. I need to go take care of my daughter. I'll be right back. All right, guys, I'm back. Sorry about that. So, TI users, I'm gonna type in the same way. Start with parentheses for your numerator. N is 4 times 61 minus sum of x, 12, sum of y, 23, don't forget the multiplication symbol. That's into the numerator, so close the parentheses. And I'm doing B1 first. It doesn't matter which order you do it in, just so long you know which one's which. And then we're dividing that by 4 times sum of x minus sum of x, no, 4 times sum of x squared minus sum of x squared. Close parentheses for the denominator. Okay. Oops, I messed something up. No, I closed 2 denominator parentheses somehow for some reason. There's only one denominator. There we go. And we get -1. We get -1. So there's our B1. For B0, type in this equation. Start with an open parentheses. Sum of y is 23 times 44 minus 12 times 61. That's into the numerator. Divided by 4 times 44 minus 12 squared. Let's check that out. Again, I put too many parentheses somehow. 8.75. That's what we should get because we already did it with the calculator. This is the same problem, by the way. And that is the end of how to calculate the regression equation right there. Oops, sorry. Now we can actually use this equation to estimate. So if we look at, let's look at this data. So we have x's between 1 and 5. So I could use this data to interpolate any number between 1 and 5. Or I could use this equation to extrapolate something greater than 5. And we have to actually make sense of the problem. It could have some physical constraints that couldn't be 0 or something. So we might or might not be able to have negatives. I don't know. Don't know what this real life scenario is. But if we go between the numbers, that's interpolation. If we go outside of the minimum and maximum numbers, that's extrapolation. And we can use this equation to do that, as long as it's actually a significant correlation. So predicting y value based on some given value of x, if there is not a linear correlation, so that's if r isn't significant, then the best predictor for y is y bar, there, the average. If there is a correlation, then you plug in the regression equation. So here, we've got Old Faithful. They use this example a lot in the book. I just grabbed this one time though. So we already found that there is a linear correlation. We have r as 0.926 and n is 8. So if we look on the chart, n is 8.926. It had an alpha of 0.05, but even at an alpha of 0.01, it's still significant. So there is a correlation here. So we're going to use this regression equation that we have. Assuming that the current eruption has a duration of 180 seconds, find the best predicted value of y. So if this wasn't significant, we just have to use whatever y bar is. We don't even know what it is, so we couldn't do that at this point, but they did give us the data, so we have to average that and find out what it is. But in this case, it's significant, so we're just going to plug in 180. So it's significant, check. 34.8 plus 0.234 times 180. And this, I'm just going to type in the Casio. It doesn't matter. I mean, there's nothing even remotely complicated about typing this in. And we get this, we want a decimal 76.92. So what I would usually say about rounding, we'd look at the original data set and go one more decimal. This case, we don't have the original data set, but we do have this, which should follow that same rule. So whatever decimal place that is where we're going to round to. So 76.9. That's it. That's the end. So test 4 again was primarily focused on hypothesis testing. You have one regression equation, you have one correlation coefficient. That's it. You have 2 p-tests. You're gonna have 4 z/t tests, 1 to 3 of each. It'll be random, like always. Don't know what you're gonna get. You might have 1 z test, you might have 3 z tests. You might have 2 and 2. Can't tell you. But there will be 8 problems on your test 4. And you're only gonna have 2 hours for it. So make sure you know what you're doing, people. Tomorrow we're going to go over the homework that is already posted in Google Drive. Wednesday we're going to go over the test 4 review, and we should finish it Wednesday. Thursday, if anybody has any extra questions or couldn't for some reason be there on Wednesday or Tuesday, then I guess they can ask questions then. Friday's the test. We've already got it scheduled. It's going to be between 10 and 4. No one told me you weren't available, so make yourself available. I'm going to split you in 3 groups this time so I can more easily monitor you. I'll have those groups out shortly. I'll post them on the line chat. And that's it, people. That's the end of statistics.